Buenos días, estudiantes. Es muy inteligente. Feliz Viernes? No, that's Friday. I don't know. Anyways, so Math 7 Notes 9-4 today, surface area of prisms. So when you're doing surface area, you're only going to be asked to find the surface area of prisms. You're not going to be asked to find the surface area of cylinders or cones or spheres or anything cray-cray like that. Just your prisms. And really, there are two, technically three, types of prisms that we've talked about so far. First one being rectangular, as I'm sure you remember. Next one being triangular. And then the third one is actually a specific type of rectangular prism, and that would be the cube. Right? Those cube and rectangular prisms are basically the same, and they require the same formulas, that volume equals length times width times height, if you're looking for volume. But we're not. We're looking for surface area. So whereas when we were doing volume, you were looking for those keywords of filling something up. Volume meant to fill something up. Surface area is a little different from volume. Surface area talks about the amount of 2D space, 2D because it's an area, covering the outside of a 3D object. So whereas volume is filling, I don't need to write that down. I'll write it down tomorrow. Volume is filling, surface area is covering something. So some examples that you're probably familiar with from your real life would be those things that you put under the tree around Christmas time, right? Wrapping presents. You're taking a box of some sort and you are covering it with wrapping paper to wrap it. Wrapping presents, if you're painting things like painting a box, painting a jewelry box, whatever kind of thing. Um, because surface area is actually area, it's always going to be measured in square units. So that can get a bit confusing because we have our volume measured in cubic units, but because we're going back to area, surface area, it's always going to be square units. So centimeters squared, inches cubed, inches squared, etc. Faces, making sense because, surface area has the word face in it. Faces, that definition back from 9-1, faces are just the sides of those 3D shapes. Now, this is the part over here where you're going to want to star highlight. If you're stuck, you want to come back and read on how to find the surface area. And what you're going to do to find surface area is first, shockingly enough, you're going to find the areas of all the faces, hence the name surface area. So you're finding the areas of all the faces, there will be multiple of them, and then you add them together. And then add them, and of course adding them gets you your total SA. SA standing for surface area. We'll use that abbreviation quite a bit. To assist you in seeing what shapes, make up a 3D figure, you can use the nets to help visualize. And what a net is, if you are unfamiliar with a net because it's been a hot minute or whatever, a net is just what happens when you take a 3D figure. I'm sliding down here. When you take a 3D figure and you quote unquote unfold it, right? And you can see the shapes. You can see the different shapes that make up a 3D figure. So nets are just the unfolding of 3D shapes. So unfolding. And the purpose we unfold those shapes is to see the 2D shapes it's composed of. So we'll get into that in the next examples.